Welcome back. Um, okay, let's continue. We took enough break, so 13's prime gap is 14, and we need a square matrix that gives us complete coverage up to 12. That's fifth square matrix. Okay. By the way, let's take a break from mathematics. Okay. Let's talk about something else. I'm a single guy, adult, so uh, you know, yeah, I do watch adult films in the internet. Okay, and let's give us some appreciation for adult film actors and actresses. Okay, so yeah, I just wanted to mention. Okay, yeah, because yeah, single guy, adult man, we kind of need that. Okay, so entertainment, adult entertainment. Okay, so yeah, their labor service is very much appreciated. Okay, I just wanna give them words of appreciation. Okay, that's all. All right. So I wrote down some functions. It's index functions. Okay. What we need to prove is that it's kind of like inverse function in a sense. Okay. Index index of 14, for example, which is index of uh, 30's prime gap is 30. Okay. Now, index of 12, prime gap 12, which is index of fifth prime gap is 5. Okay. So 30 is 5 is a lot less than 30. Okay. So that's what we need to prove. Okay. What we need to prove is that uh, index of Gn is larger than index of Gn minus 2. Something like that. Okay. So something like that. But isn't this kind of obvious? when any 30, all right, g of n is 14, right? And 14 minus when 80 30, all right? Okay. G30 is 14, so 14 minus 2 is 12. Okay, so no, no, it's not that. Yeah, because yeah, uh, it's more than that. It's index of. Give me a square matrix whose continuity. Okay, okay. Give me a square matrix that whose. We're gonna need another whiteboard. Okay. Give me a square matrix whose complete whose continuity maximal is gn minus one. Okay, so um, goodness. Wow. We'll grab out of the whiteboard. Okay. Oh boy, this is. Whew. Difficult question. Wow. It's involved. I'm gonna erase this guy because this is wrong. Alright. Oh boy. Wow. Yeah, we are gonna make a hypothesis. Alright. We're gonna define some functions. Alright. And try to prove it. Oh boy. Okay. So. Okay. What we have over there is index function. It's just inverse function of gap function. Okay. Index of g 30. It just gives us 30. Okay. And g30 is 14. 14 is 13's gap, prime gap. Now, the gap filler matrix, alright, the first column is accumulation of prime gaps. Okay? we'll just define it as the very first column. Okay. All right. Okay. So we have n by n matrix. All right, and let's make examples. All right. So gamma 5 and continuity maximal thereof is 12. It contains 2, 4, 6, 8, 10, 12. Okay, so continuity maximal is 12. Now, we just name J. Okay, J of 12 is 5. Okay, so it's kind of like inverse function of this continuity maximal function and also extract the index of that. So okay, so that's J. Okay, so now we know 30 is more than 5. Okay, cheers. And this is left hand side. Okay, I 14. Right hand side let's line them up neatly. J of 14 minus 2, which is J of G30 minus 2. Okay? Alright. So what we want to prove is that I of G n that's what we need to prove. Okay? I mean, yeah, this is equivalent as okay. Yeah, just making some examples here. J is just index of the smallest matrix, okay, n by n matrix, okay, it's just the size of the matrix that gives us complete coverage of even numbers up to gn n squared minus 2. Okay, so if we prove this, then we are done. Okay, so this equivalent problem to Goldbach's conjecture. Okay, so yeah. Okay. Oh. Okay. Yeah. It's a lot smaller problem. Okay. So, but mathematical equivalent there. Mathematical equivalency. Uh, we prove it after we done proving this. Why? Because this is more important. Mathematical to prove the mathematical equivalence between two conjectures, that's easy. Okay, that's very mechanical process. But this is a difficult part, and I don't think it's too difficult though. Okay, I think we may be quite close of proving Goldbach's conjecture. I think. Okay, because we just need some time to think about this. All right, but I don't think we're too far away. Okay. Maybe a couple of more days, perhaps. Okay, possibly. Okay. Yeah, I think we're closing in, zeroing in to this. Our goal. Proof of Goldbach conjecture. Okay, so if you can prove this before I do and publish it, go ahead and do it. Okay, I have no problem with that. Okay. Actually, I prefer you do. Okay, so that I don't have to. Go ahead, surprise me. Okay. Actually, it wouldn't be too much of a surprise to me if you prove it first. Okay. Because we're almost there, right? So, yeah. But please do let me know so that I don't have to do it myself. Publication, no, not a huge fan. Too much work, okay? Please do let me know so that I don't have to do it, okay? So, yeah. How do you let me? You can let me know? Yeah, just put in the comment in the YouTube, okay? So that I don't have to replicate your effort, all right? The publication that's a long process, all right? So, okay, I'm looking at that whiteboard, previous whiteboard. Ah, boy. Kind of getting sleepy. Mm. All right. Excuse me. Mm. J function, it returns index. Okay. Here you have J12, right? So give me the index of that square matrix n by n. If n by n matrix return give me n such that that square matrix its continuity maximal is 12. Okay, so it has to be fifth square matrix. Okay, so that's what J means. So yeah, it returns 5. Okay, so index function. Okay, so, and so when let me look up that prime gap list again. Um, Prime gap it grows so slow, and I went to Oasis. It doesn't even in their list doesn't even have the number 16. Okay, you see, because they calculated prime gap all the way until 97th. 97th prime gap. And they don't even have number 16. Okay, it's very slow growth, very logarithmic, right? They calculated like up to 200, and the maximum prime gap is like 20. All right, so okay. We have found a lot of different things here, so go ahead, publish this, even if you haven't proved Goldbach's conjecture yet. This is what we have done so far is still publication material, okay? Because we made a lot of discovery here, okay? So you can still publish this as it is. Just let me know, okay? Yeah, because I don't want to repeat your effort, all right? But if you do prove Goldbach's conjecture before I do, please let me know, okay? So that I stop working on this, okay? If you prove this and publish this, then there's no need for me to prove this and publish this. I'll just stop. Why? You proved it, okay? I don't want to replicate the effort. So please let me know so that I don't waste my time on this, okay? I just want it to be proven by me or by you, by somebody, okay? It doesn't have to be me, alright? So, So let's say you have like 200 prime gap number, right? It's like 20 something, okay? Then, so you have 200, right? And n is 200, and for example, and 200th gap is like 20, okay? So 20 minus 2, 18. What is j of 18? 7. Okay? Is 7 less than 200? Yeah. Okay. Of course. So this inequality is a very easy inequality, okay? Because 7 is by far less than 200. So I'm guessing it shouldn't be too difficult to this. It should not be too difficult to prove this inequality. Why? Because the gap of this inequality is pretty big. Like 30 is, of course, bigger than 5. It's not a very tight inequality. No, it's very loose, easy inequality. So that's why I'm guessing it shouldn't be too difficult to prove this thing. We're gonna have to define some more functions, okay? So let's say in our gap filler matrix, okay? We call it iota, iota for index, okay? Iota of some number 114. How big this n by n square matrix become in order to have all the even integer coverage up to 114? And it turns out to be 45. Okay? 45 by 45 square matrix, gap filler matrix, it gives us complete coverage of 2 all the way to 114, or the continuous even number coverage. Okay? An index of 116, it happened to be also 45. Why? Because 114 was missing, right? So all the way until okay, we're gonna define many functions, okay? Because we need some tools to express the behavior of this gap filler matrix. That's why it's so important that this systematic enumeration method, it always pays because we observe numbers and their behavior, the behaviorism of numbers. Okay, so okay. So continuity maximal of gamma 29 is 112. Continuity maximal of gamma 30 is also 112. Why? Because 114 is missing until 45th. Okay, continuity maximal of gamma 44th is also 112. Why? Because 45th gap filler matrix is that's the only time, that's the first time when we see 114. Okay, just making some observation. All right. We may be able to prove something stronger than Goldbach's conjecture. Okay, so if we prove some proposition that is stronger than Goldbach's conjecture, more generic, that encompasses Goldbach's conjecture, then we are done. Because sometimes in mathematics, that's how they prove. Like Professor something like Andrew Wiles, who proved the Fermat's last conjecture, because it used to be conjecture, now it's Fermat's last theorem. He, from what I recall, he proved something even more general, more stronger, bigger. Okay, so in mathematics, sometimes it's easier to prove something more stronger, something more general. All right. So perhaps that's the approach we should take. Okay, perhaps it's easier to prove something more general than Goldbach's conjecture. Okay. Okay. Yeah. It's kind of roundabout way of proving it. We'll take 5 minutes break. Okay. So. Okay. Whew. Oh wow, this is like heavy. Whew. Let's take 5 minutes break. Okay. maybe I should apologize, to make light of Corona situation because, yeah, some people die, some people suffer from it, so maybe I shouldn't take light of that. But I was wondering, what do you do? I mean, if your city is lockdown mode, what's your hobby? What do you do at home? Me? We are not in lockdown mode. No, not where I live. Alaska, in some southern cities, it's more serious than others when it comes to corona stuff. But my town, we can go to parks. I go to parks during my lunchtime. I run. Yeah. Uh, so I was just wondering what you do nowadays. If your city is in lockdown mode at home, join me. Okay? Yeah. Do mathematics with me. Okay? Yeah, it's a good hobby. I mean, I've been doing this. My town is not in lockdown mode. I've been doing this for like 2 years by now. Okay? Yeah. So nothing changed really. No. Okay. 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 We'll continue to like small. Yeah, this is the index, square matrix index, n by n, 44 by 44. Okay. And this iota is just inverse function of that, right? Yeah, kinda. What's the index of this iota of this? Yeah, 44. Okay. So I think that's all we need, right? So okay. If you have j function, index function, and the gap function, okay, nth gap, prime gap, okay, yeah, that's all we need. That's all. We got tools now. Boy. Nobody's perfect, right? I mean, I drink alcohol, I smoke cigarettes, right? But uh, I think smoking cigarette and drinking alcohol is, relatively speaking, healthier than eating sugar and fat. Okay, because uh, sugar and fat, that's very popular in America, right? So overweightedness, that's something very serious. Okay, uh, diet and exercise, I think that goes a long way, right? So I just want to point that out. Okay. Yeah. Yeah. Okay. All right. Because many of my American friends, also Korean, not so much Korean friends. Okay, many of my American friends, they are overweight, and as you age, it has a lot of complication with overweightness. Okay, so uh, that's, yeah. Look at President Trump. Let's take a break from mathematics for a second. Okay, President Trump, State Secretary Mike Pompeo, Mr. Trump, Mr. Pompeo, they're overweight. Okay, so um, but they seem to be healthy, right? So maybe being overweight isn't too bad, huh? I don't know, okay, but it does cause a lot of problems. Okay, so yeah, maybe it's not too bad. Okay, I'm President Trump in his 70s, right? He seems to be quite healthy. Okay, maybe it's not too bad. Huh? I don't know. Okay. Okay. I think President Trump is handling Corona situation just fine. Okay, I mean, I would do it differently, but he's not handling it too wrong. Okay, he's making some compromises, and he's doing just fine. I think. Okay. 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 Yeah, I've met some famous people like senators, congressmen, uh, governors, and they're cool people. Okay, and they're very knowledgeable. So yeah, and I learn a lot from them too. Okay, yeah, they're very knowledgeable, very informed people. So never met a president though. Okay, all right. What if we prove again? We're gonna come up with different conjecture. All right. How about brown? Not thick enough. How about green? We just use black. What if we hypothesize um, how about that? Some observation, all right. So it's a hypothesis. Yes, conjecture. And is it equivalent to Goldbach's conjecture? Yes, it is. Okay. Uh, Continuity maximal do not always grow. We saw it, right? Sometimes it just stay the same. Continuity maximal, right? So it's not obvious to us that it will always be the case. Okay, because uh, but from what we observe, the speed of growth of continuity maximal as n increases, it's always ahead by far ahead of this prime gap growth. All right, and asymptotics like prime number theorem. That's not gonna solve us. All right, so we cannot quite take advantage of that. Why? Because asymptotics, that's like when n goes to infinity and it kind of behave that way, kind of like logarithmic. That's not of much to of use to us. Okay, so it helps give us some assurance, right? But yeah, doesn't help us very much. Okay, I appreciate what they did. Okay, what Muzi Hadamard or something, Muzi Busan. I appreciate what they did. Okay, but we're taking a different approach. We'll take a break very soon. Okay, so let's just think about this for a second. Why does this grow faster than this guy? Well, first of all, prime maximal, I mean the continuity maximal, it never decreases. It can stay the same. Okay? It can stay the same. But it never once decreases. Why? Because it's maximum even number with continuous coverage of even integers. And as n gets bigger and bigger, we are adding prime gaps. Okay, so number always increases. Okay? Prime gap, on the other hand, it does go down sometimes. Like half the times. Well, one third time. Okay, because prime gap, sometimes it stays the same, sometimes it go up, sometimes it goes down. Like twin primes, twin prime conjecture. There will always be twin primes. Prime gap, 2. It's a conjecture, right? But not been proven yet. In prime number theory, there are a lot of unproven conjectures. So it's a very fertile land, a gold mine. Okay? Riemann hypothesis, it got $1 million prize. And it's kind of have to do with prime numbers. Okay? But I'm not interested in that problem though. It's too much calculus. Okay. Complex number and all that. We'll take 5 minutes break, okay? So yeah. If we prove this, that's Goldbach's conjecture proof. Okay. So, it is equivalent problem, okay? And equivalence, yeah, we can prove it later because that's easy. Alright, so very mechanical. Yeah. We'll take 5 minutes, okay? Alright. Okay. So I have very good feeling about this conjecture. Okay, mathematical equivalent hypothesis to Goldbach's conjecture. Okay, so because this gap filler matrix, it always grows. Okay, yes, but when it comes to maximal, continuity maximal, it can stay the same, but it never go down. But prime gap, it does go down. Okay, it grows somewhat and then it go down, go up, down, stay the same. The maximum prime gap so far, it increases very slowly in a logarithmic fashion. Okay, and how about this prime maximal? It grows quite fast. Okay, so that's the idea. Okay, yeah, okay. Let's take a break from this. Okay, so exercise and diet very important. All right, why? Because yeah, I smoke cigarettes, I drink alcohol. Okay, but if I exercise and diet, it kind of cancels out. All right, so uh, and have a good hobby. Okay, so then you'll be healthy and happy and beautiful. All right. Okay. So is this always the case? Well, yeah, the maximal, the continuity maximal, it's just you look at this n by n matrix array of numbers, two dimensional, okay, and you look at even numbers, and what's the maximum even number before which give you complete coverage of even numbers all the way from 2, 2, 4, 6, 8, 10. Okay, so that's the prime, the continuity maximum of this set. Okay, yeah, it does slow down, right? It does stay the same sometimes, but as we saw in the 45th, okay, um, it increased again. Okay, yeah. Will it always increase this maximal? It depends on another hypothesis where does prime gap covers entire gamut of even integers. Does prime gap covers? So another conjecture that's mathematically equivalent to Goldbach's conjecture is this. Okay, kinda. Okay, uh, is prime gap set of prime gap? We are running out of alphabet here. We call it GS, prime gap set. Is it equal to even numbers? Okay? If this is so, I mean, it's not mathematically equivalent, I don't think, but it makes this more likely, okay? So, yeah, because who knows, maybe prime gap function, it will catch up with maximal function, okay? It's not likely, but uh, If this is true, then yes, maximal function it always increases. If this is not true, then maximal function gets stuck and stop increasing. And yes, prime gap eventually will catch up. Okay? And this will be untrue, and then yeah, Goldbach's conjecture, it may be disproven or unproven, I don't know. First, this is a good starting point. Okay, we made a lot of progress over the weekend, alright? And it's kind of getting late, right? 11 o'clock, 10 o'clock, what time it is, I don't know. Okay, 10 o'clock, something like that. But I took a nap, so I'm not sleepy. Okay, so because this OEACs, this prime gap list, 200 prime gap or whatever, 100 prime gap, I didn't see 16. Right? I saw 10, 12, 14, even from Wikipedia's shortened list, but I didn't see prime gap 16. We have that pyramid, right, somewhere. Prime gap pyramid. I didn't erase it. Yeah. Yeah, it doesn't go that far. Alright. Okay. Okay. So how do you stay healthy? It's this. Okay, diet, exercise. Okay. You have to be physically active. You have to run, do cardio, muscle exercise, and also you need to learn martial arts. Okay, and dancing. Those are very good for joints, and so that if you do dancing, martial art, you learn about balancing. Okay, and yeah, agility. So yeah, so all about good healthy diet and exercise. Okay, that's what health is about. Okay. Yeah. Okay. If prime gap set is not equal to even integer, then prime maximal it will stop growing. Why? Because there will never gap filler. All right. Yeah. So perhaps we have to prove this first in order to prove this guy. It seems to be necessary. Oh wow. Because if this guy stops, prime gap will eventually catch up. Okay, so and this will be untrue. All right, and we don't want that to happen. Okay, so or if it happens, fine, whatever. If we ever prove this, it's gonna be quite lengthy paper. I'm not sure what Mr. Pogorzelski he said he proved it, Goldbach's conjecture, okay, and it was not widely accepted and was kind of rejected by mainstream journals. But he said he proved it, and he may have, right? Yeah, and it's a lot of pages, like hundreds of pages or thousands of pages, because uh, but he said he proved it, so yeah, I don't know. He may have. I don't know. This gap set is equal to. Does it cover all the even integers? Because according to prime number theorem, one implication from what I read from Wikipedia is that prime gap grows asymptotic behavior when n go to infinity. Its growth is logarithmic, so it go to infinity, right? Okay, then so should maximal. But prime gap can grow whatever big, but for this maximal to grow to the infinity, this has to be true. Prime gap set has to cover all the even integers. Okay, so that's kind of obstacle that we have to overcome. Okay. Oh my goodness. We can prove this or disprove this. If we disprove this, then we're gonna disprove Goldbach's conjecture. So one way or the other, I, we're gonna either prove Goldbach's conjecture or disprove it. Okay. So we are okay either way. We don't have fixed agenda. No, we are scientists. We just observe. Our hypothesis could be wrong. That's fine. Okay? We are not advocate of Goldbach's conjecture. If we disprove him, that's fine too. We are scientists. We are objective. Okay, so. Hmm.
Let me look up prime gap list, the biggest list that they have online available. It's not quite giving me much. I'm reading some magazine article, mathematics magazine article, some about prime gap. Yeah, some contemporary mathematicians, what they do, some jokes. How refreshing. Oh boy. Okay. Yeah, there's some Chinese American mathematicians like Mr. Cannot pronounce their names, but yeah, in prime number theory. Okay. Impressive. Okay. Sorry. Reading some articles. Yeah, there's some this Chinese American mathematicians who made some contribution. Okay, whatever. Okay. Those prime gap set give us complete coverage of even numbers eventually. Ah, boy, that's good question to ask. Is roadblock for us? Okay. Is this necessary? I'm not sure. Hmm. We'll see. When prime gap is 14, yeah. Okay. Yeah, it seems to be necessary. Okay. Yeah, some Chinese American mathematician proved something like something quite surprising. He got Wolf medal for it, okay, and then Wolf Prize, and then I think I read his biography, okay. After he found that something like no matter how big prime number becomes, yeah, this prime gap of something like 70 million or something it will always be there, and other mathematicians improved that. So yeah, the prime gap 234 something like that it will always there no matter how big prime number gets. Okay, and twin prime conjecture is no matter how big prime number get, there will be always prime gap too. Okay, so they did prove up to down to 234 something like that. Okay, so I just read from this magazine, mathematics magazine. Okay. So what does we need? What do you need for this prime gap set to be to have complete coverage of even numbers? Uh, it's that we may have to start talking about prime gap. Okay. If there is always okay, so you have prime gap set. Okay. Let's switch to the whiteboard. Okay, so we'll take 5 minutes. Okay, and then we'll bring up that prime gap pyramid triangle. Okay, and we'll think about it. All right. Okay. It's difficult problem. Yeah. Come on, it's prime number, right? It is difficult problem. No surprise there. So. Yeah, let's talk about this Chinese American mathematician that I read about. He won this Wolf Prize in mathematics. There are three prestigious prize in mathematics. Okay, Fields Medal, that's for young people, right? Under 30, I think. And Wolf Prize, Abel Prize, no age limit. Okay, so he won. From what I recall, I read about him. He was a lecturer, instructor in some university in mathematics department, and during his spare time, he wrote paper, and he got published in a major mathematics journal, and he got Wolf Prize, and he got a professor job, okay, in America. So, yeah, he proved that prime gap, something like 70 million or something. Yeah, you get always preserved, which is a very good find. And other mathematicians they improved that and reduced the number prime gap number down to 200 or something. Okay, so which is great. Yeah, but yeah, let's switch out the whiteboard. Okay, and look at the prime number, a prime gap pyramid triangle, whatever you call it. Yeah. Let's just observe, alright? So, does prime gap, I mean, they proved, I mean, implication from prime number theorem, uh, the asymptotic growth of this prime gap is logarithmic, so it goes to infinity, okay? But we are interested in whether this prime gap covers entire continuous even numbers. Okay, that's what we are interested in. Okay, so let's look at prime gap. All right. Yeah, it goes to negative. Okay, sometimes half of times. So prime number it increases sometimes. Sometimes it decreases. Very slow growth. Okay. I don't know too much mathematics, okay, like those people, but for what I know, I do my best. Alright, so because I do this as a hobby. Okay, so, like Mr. Ferma, Muzio Ferma, and he was a lawyer. He was also a judge. Okay, and Mr. Goldbach, Gospodin Goldbach, Herr Goldbach, he was also a lawyer. Okay, so lawyers they make a lot of conjectures, some observation, but they're not professional mathematicians. Okay, I'm a lawyer too. I'm also amateur mathematician. Okay, okay. What we noticed is that as you differentiate prime number function, the derivative actually goes to infinity, absolute value thereof. Okay, so that was quite a surprise because functions, known functions, don't behave like that. Okay, I mean trigonometric function. Okay, if you differentiate, yes, sine, cosine, right? Kind of stay the same, and exponential function. If you differentiate again and again, like yeah, it increases somewhat, right? Y is equal to 10 to the x, differentiate ln 10, which is more than 1, and ln 10 times again. Yeah, it does increase. Okay, fine. But this was kind of surprise to me. Okay, so Okay. But bottom line, it's not quite logarithmic. Okay. It's more exponential. Okay. Just like y is equal to 10 to the x, you differentiate it again and again, you tend to increase. Okay. So it behaves like exponential function, not logarithmic. Okay. So that's quite a surprise. Anyways, I guess we kind of encounter some kind of roadblock here. All right. Because unless we prove prime gap set covers continuous even numbers, then we are kind of stuck. All right. So and equivalence between prime gap set and even integer set, that's I have no idea how to prove it. All right. Let me sleep on it. All right. Maybe there's some other way. I don't know. Boy, we may have to abandon this, okay? Because equivalence between prime gap set and even natural numbers. Boy, I feel like it's way beyond me. Okay, so I may have to give up on this. I'm sorry if I failed you. All right, because that's we made a lot of contribution to mathematics. Okay, but that's that seems to be beyond me. Okay, we may have to leave this to pass this on to professional mathematicians. Okay, we did contribute quite a bit. Okay, but when it comes to me, I'm not a professional mathematician, and I don't want to be. Why? Because I have other interests. All right, I need to do humanology, economics, and other stuff. Okay, so mathematics, I don't want to dedicate my life to mathematics. Okay, it's one of many things that I do. Okay, so I'm kind of wondering, Professor Bogorzelski, if he really proved it. Okay, so I went to Amazon.com. Okay, there's one book left in Amazon.com, the book that he wrote. It was like $120 or something, and I didn't buy it. Why? Because I'm not a good keeper of books. When I move out of state, something like that, I discard everything: my furniture, clothing, books. I don't have time to donate them or sell them. I just put in the trash can. Okay, so if there's one book left, I cannot buy it because it will get lost. Okay, so but if I were you, yeah, I would study what Mr. Bogorzelski did, and because perhaps he proved it. Okay, Goldbach concession. I don't know. But that one book in Amazon, it should go back to the library so that it get preserved. So I could not possibly buy it. Okay, so I don't know what I'm gonna do. All right, because this roadblock we encountered, okay, is prime gap set is equal to even natural number set. I have no idea how to prove that. Okay, so we may have to abandon this project, right? Because we made tremendous progress. So let professional mathematicians continue on. Okay, learn from us. Maybe they'll prove it. Okay. I don't think I can't. I don't think I can, and I don't think I want to do that. Why? Because it seems to be problem bigger than what I can solve. All right. There's world out there outside of mathematics. Okay. So that's my approach. I mean, mathematics fun, okay, but there are other things to do than mathematics. All right. I do martial art, humanology, and other stuff. Okay, so I sleep on this. Okay, and we may have to leave this for good. Okay, and abandon this gold box conjecture proof project and do something else. Okay, I'm sorry. For now, it seems to be beyond me. All right. So I'm kind of wondering whether we should continue on this or not. Prime gap set. Maybe I should start programming a little bit in JavaScript. Prime number generator, prime gap generator. Okay. Uh, I don't know. But programming, oh, that takes a lot of time. Okay. Not sure. Yeah, we are on this crossroad. Should we leave this for good, or should we put in the back burner, or should we continue? Crossroad. There are three different ways to go. Again, I'm not sure. So that mathematical magazine that I just read, it talks about they talk about composite numbers. Yeah, prime gap or between prime gaps, they are composite numbers. Okay, yeah, 23 and 29, 24, 25, 26, 27, 28. Yeah, they were composites. Okay, okay. Because prime numbers, they are not random. All right, prime numbers is natural number minus composite numbers. Set subtraction. Okay, and composite numbers, they are very regular. They're not random. Yeah, just multiples, right? Con- yeah, that's easy, right? Okay. So prime gap is the number of composites between two adjacent primes. Okay. This is Bertrand's postulate, right? She was proven by somebody. What's his name? I forgot. Yeah, Gauss-Bogin-Chebyshev theorem, right? Bertrand-Chebyshev theorem. Russian gentleman. Okay. Yeah, between n and 2 times n. Yeah, you always find a prime number. Okay, so, which is really cool. Okay. So, all right. I'm kind of wondering who came up with twin prime conjecture. Let me look it up. Who came up with twin prime conjecture? Polignac. All right. Let me read his biography. French mathematician Mr. Mousseux Alphonse de Polignac. Unfortunately, he kind of died young, huh? 37? Okay. Too bad. In 1800s. Okay. Not much is known about this gentleman. He went to Eco Polytechnic, which is very prestigious school in France. All right. Every even number can be expressed as the difference between two consecutive primes. So Mr. Can't even pronounce his name. Mr. Polignac So he did more than twin prime conjecture. Okay, he did something else. Okay, one of the conjecture he came up with is that every even number can be expressed as the every even number can be expressed as difference between two consecutive primes, which is the conjecture that we have. Yeah. Does prime gap cover the entire even number? Okay. Okay, he came up with that first in 1800s. Good, good. All right, very good. Hmm. Okay, we take 5 minutes break. Okay, so yeah, Mr. Polignac came up with the same hypothesis like we did here about 200 years ago. Good. Okay, we take 5 minutes. All right. All right. Interesting problem. Okay. Yeah, we'll spend more time on this. Okay. Yeah. All right. Because it's interesting. All right.
Okay. Yeah, looks like we're gonna give it more time. Okay, we're not gonna give up on this, not yet. Okay, because we are learning from other people, and let me get some water. Yeah, I'm cooking my dinner. Kind of late dinner, by the way. So, Monsieur Polignac, a French mathematician, unfortunately, who died young in his 30s, he came up with this kind of dual, kind of flip side of Goldbach's conjecture. Goldbach's conjecture says any even integer can be expressed as summation of two prime numbers. Okay, that's Goldbach's conjecture. We're trying to prove. Monsieur Polignac's conjecture is the flip side of that. It states every even numbers can be expressed as subtraction between two adjacent primes. Okay, and we kind of rediscover that conjecture. Okay, which is mathematical equivalent to proposition that states prime gap set is equal to even positive integer set, non-negative integer set. Okay, so yeah, I'm glad I'm not the only one who thought about that. So 200 years ago, yeah, Mr. Polignac conjectured that too. Okay, in France, over places. Yeah, let me continue to cook my dinner. Okay, so. Where's my milk? I gotta warm my milk. Okay. All right. We need to prove two things, it seems. First, we need to prove Monsieur Polignac's conjecture. Second, we need to prove that the speed of growth of this maximal, continuity maximal function is faster than prime gap function. Okay, then we are done. All right, so okay. I'm not sure if I can do this. All right, proof of Polinac's conjecture that's
uh, yeah, I'm not quite sure if we should continue on this because it's. I have no idea how to go about it. All right, just drawing blank. Totally. I mean, I can study more mathematics. Okay, read some articles and learn more about it. But do I feel like it? No, no. So I got other things to do too. Okay, so I'm not sure if we're gonna continue on this or not. Okay. I'm asking God. God, do you want me to keep doing this, or do you want me to do something else? I don't know what you want me to do. Lord, God, I'm not sure. The two adjacent primes, huh? Yeah, they're composite numbers between. Okay. So, prime gap can be defined as the number of composites between two adjacent primes 32, 33, 34, 35, 36, plus 1. Okay? Number of composites plus 1. Okay, okay. And we know a lot about composites. It's very regular stuff. Okay. And we know about this Bertrand Chebyshev theorem. Okay. Maybe there's a way to prove this. Polinak's conjecture. Okay. Let me look it up, okay? Polinak's conjecture. Maybe we can, okay? Yeah, President Trump, he said, you never give up, right? Yeah, he got some good stuff, okay? Maybe we shouldn't just give up so easily. It's been only 1 month since we started all this, alright? Goldbox context proof project. Maybe we should give it some more time, huh? Okay. 'Cause Professor Freeman Dyson, he said, yeah, typically he focus on one project and give it at least a year. So he said something like that. Because maybe we should give it a year, huh? It's been only 1 month. So, okay. Maybe I should start studying the Riemann zeta function. Maybe I don't know. Uh, because I think it's a very cool theory. Okay, kind of connecting the dots between prime numbers and polynomials, complex numbers. I think it is really cool, beautiful theory. Okay, but it's just too much mathematics involved in there. So I'm kind of resisting from to learn it. I have some reluctance. Okay, so because I want to take a different approach. Okay, so all right. Number of composites plus one. That's what prime gap is. Okay. Number of composites between two adjacent primes plus one. Okay. So equivalent hypothesis is this. Does the number of composites between two adjacent primes, does it cover a complete set of odd positive integers? Because composites are more regular than prime numbers, okay, so that's easier to deal with. Just multiples, right? So the number of composites between two adjacent primes, does it cover the entire odd integers, positive integers? Okay, so let's write it down, okay, before we forget. So number of composite between the set of composites between pi, ith prime, and next prime, this set, we call it C, okay? Is C equal to positive odd integers? Okay? So that's the equivalent problem to Polignac's conjecture, okay? So, okay, we know that much. So we're not going to deal with primes anymore, okay? We're going to deal with composites, which is a lot easier, alright? So, okay. We'll leave it at that, okay? And we'll get back to this tomorrow, okay? Okay. If that. Because yeah, let's continue. Let's give it one more month. One more week, okay? Just there's no reason, rhyme or reason to give it up. We can always put this gold bus project in the back burner and get back to it, alright? So we made some good progress today, alright? So this weekend. Alright, I will see you tomorrow. Thank you. Be safe, okay? Be healthy. Bye.